Okay, let's dive right into this explainer. We are exploring a paradigm shift so radical today, it literally challenges the very foundation of how we interact with computers. We're talking about SexOS and its deeply fascinating Lenin file manager. Together, they're completely reinventing how we save, store, and run software. Honestly, if you're used to traditional folders and directories, prepare to have your mind blown a bit, because we are looking at a future where the whole concept of a file folder is completely obsolete.
So here's our agenda for today. We'll start with the death of POSIX and the concept of one global address space, right through to the Lenin causal storage graph. Then, we're actually going to walk through exactly how you save files, run apps, and achieve a zero-copy future in this entirely new system.
All right, Section 1, the death of POSIX. Let's get into it. Okay, take a look at the legacy way of doing things on the left side here. We've got hierarchical folders, siloed memory requiring heavy context switches, and you're constantly copying data back and forth just to read a single file. Now compare that to the CLexOS way on the right. We've got causal graphs instead of folders, a completely shared memory space, and zero-copy data access where memory capabilities are literally just lent out. It's a massive shift from managing, unpredictable chaos to mathematically deterministic order.
Moving on to Section 2, one global address space.
So, SaxOS is what we call a SaaS-OS. That stands for Single Address Space Operating System. Think of traditional systems kind of like a building full of locked cubicles. Every single process lives in its own isolated room, requiring heavy page table swaps just to pass a simple message down the hall. A SaaS-OS, on the other hand, well, it's like one giant open plan floor. Everything, the kernel, the Silk desktop environment, and the Linen file manager, it all lives in this single giant 64-bit physical memory map. There are literally no traditional software boundaries at all.
Now you might be wondering, if they share memory, how on earth is that secure? Well, instead of heavy software walls, SexOS uses Intel PKU. You can think of these as 4-bit VIP wristbands for your CPU. Even though an application can technically see the memory address out there on that open plan floor, if its thread doesn't have the matching 4-bit color wristband, the CPU instantly blocks access natively at the hardware level. No way around it. This lets us switch domains in just 20 to 40 CPU cycles rather than thousands. That is absolutely huge for performance.
Okay, Section 3, Linen, causal storage graph. If you take away anything from today's explainer, please let it be this. Linen is not a traditional POSIX file manager. You aren't opening a folder to find a file. Instead, you're exploring a web of causal user graphs. Linen acts way more like a visual debugger for causality over persistent storage. Files are simply nodes in a timeline that track the latest causal successor of an object.
So instead of modifying a file in place and risking total corruption if your power suddenly cuts out, Linen treats every single change as a new node tied to a memory epoch. You go from state A, you edit it to state B, and then it commits to a ledger. The end result? A crash-safe, version-controlled timeline woven right into the actual physics of the operating system. Which brings us to Section 4, saving files in Linen. Let's do a quick demonstrative example. Imagine you're typing a document and you hit save. Here is exactly what happens under the hood, completely bypassing any concept of folders. Your hardware pushes the data directly via DMA into a block page. That maps to a logical storage region called an extent. It's then securely recorded in an append-only journal via an inode. And finally, it pops up in Linen as a file object. Linen isn't digging through a C drive directory to show you this. It's really just observing this immutable storage pipeline in real time.
And here's where it gets wild. When you drag and drop a file in Linen to open it, you aren't actually moving any data. It's exactly like handing someone the keys to your car instead of building them an exact replica of it. Because everyone shares the same memory space, the kernel simply alters the hardware visibility mask. It updates a ledger and retags that specific chunk of memory with your application's 4-bit hardware capability color. It is a completely zero-copy handover.
Which naturally brings us to a really fascinating question. If we don't have traditional folders, like no C drive, no user bin directory, how do we actually organize, install, and execute software in this entirely new system?
Let's answer that in Section 5, running apps via capabilities.
Let's walk through how you actually get an app in this environment. A server called SexShop acts as your package manager. But, and this is key, it doesn't unzip files into a program directory. It pulls an immutable blob of data straight from an object network right into the shared global memory.
Next, to actually run it, a spawn orchestrator called sexnode takes over the process. It dynamically carves out virtual memory from the global heap and mints a brand new protection domain, handing it its own unique 4-bit hardware key.
Finally, the Silk Shell user environment spawns the app, but remember, it's not a traditional process. It's an event-driven capsule. This capsule runs in the exact same memory space, but is completely isolated by that CPU key we talked about. It receives inputs mathematically ordered by the causal graph. And the best part? If the app crashes, the system just drops a tombstone on the timeline and instantly restarts it without ever taking down your desktop. It is a real game changer.
All right, Section 6, a zero-copy future.
So, what does this all mean? By collapsing time, memory isolation, and execution into a single causal ledger, Sexos and the Linen interface give us 3 massive benefits. First, zero-copy throughput. Memory is shared and hardware-gated, never copied. Second, perfect fault containment. A crash in one capsule absolutely cannot corrupt the immutable ledger. And third, mathematically deterministic execution. Because every state is tied to an epoch, the system is completely predictable and crash-safe by design.
It is a radical leap forward for computing architecture. Seeing how seamlessly Linen handles data as nodes in a web of user graphs rather than files stuffed in a drawer really leaves us to wonder. Is the traditional file system finally obsolete? Are we actually ready to permanently abandon folders and step into the causal graph? It's a thrilling prospect, and one that could for sure redefine performance and security forever. Thanks for joining me on this explainer today.